first we finish the example we talked about last time. We have a little bit left. So if we want to find out, if you're gonna do a survey and you want your sample mean to be close to the population mean, and you want to know how many what's the sample size, and what you can do is to use this formula to determine your sample size. So if we want to be 95% certain and such that the error margin is less than 1 hour. So the example we did before, the error margin, we found out it's 1.6 hours. We have 40 sample, the sample size is 40 and 95% confident, then the error margin is 1.6 hours. What if I want my error margin to be 1 hour? Okay, so what we need to do is we only need to change D, the error margin here, to be 1, and so we use calculator to find out 1.96 times 5.17 is about like 10.13, and then square it, we get about like 103 as the answer. So that's the sample size. And so you can see if you want the error margin to be smaller, and you need to increase your sample size. Of course, if you only want your answer to be, say, 90% certain, and then you can go back to the table. Here 90%, the z-score is so you only need 1.645 standard deviation. So I'll come here, I change 1.96 to 1.645, and I use the calculator to find out say 1.645 times 5.17. I got 8.50, and I try to square it, and it looks like I don't have a square button here, so I multiply it by itself. 8.50465, which is 72.32. So that's about 74. I say 73. So the sample size 72 or 73. So I'll just take 73 to be safe. Okay. So you can see, if you only want to be 90% confident that the error is less than 1 hour, then the sample size is you only need to find 73 students to do the surveys. Okay, so this is how we use the formula to determine the sample size. And next we're gonna look at example talking about the confidence interval. Okay, so first of all, the confidence interval is the range we talked about before. So for example, if we look at this picture here, if you want to be 95% confident that the error margin is like this big, from here to here, this big, and what you need to do is you just add, if you want to find out the range, so what's the range from here to here, and we know that x bar is somewhere in here, from this lower point to this upper point, right, somewhere here. So that means if we add this error margin to mu, you will get this upper point. If you subtract the error margin from mu, you get the lower point. So x bar is between them, and we can prove that if x bar is between mu minus 1.696, which here 1.96, we know it's 2 standard deviation from the examples before, because the error is 95% confident, the probability. And so whatever the error margin is, we can look at the previous example picture here. Right here. Okay, so this is 2 standard deviation, so it's gonna be between this point and that point. If x bar is between these 2 points, and then we can find out that so you add 2 standard deviation, mu plus 2 standard deviation, you get upper point. If you subtract 2 standard deviation, mu minus this value, you get So mu minus 2 standard deviation, you get lower point. That's the range for x bar. And this, we can prove that if we solve for mu, and you can find out x bar, mu is actually between the sample mean plus 2 standard deviation and the sample mean minus 2 standard deviation. So this is how we have the formula right here. Okay, so x bar is the average. You find out sample mean, you can add it, maybe 1 standard deviation, 2 standard deviation, 1.96 standard deviation, depending on how confident you want, so the level of confidence. And if you subtract a few numbers of standard deviation, maybe 1 or 1.5, 1.6, 2 standard deviation, and then you get a low point. So that's the what we get from the picture. So we can use this to do that example we talked about before. If we have 40 as the sample size, and this is sample mean 4.55, and you can always get the sample mean from a sample. You pick a few, 40 students, and you do the calculation. You ask everybody about their community service hours, and you also use the formula we learned before in chapter 2 to find out the 10% deviation. So if we want to find the 95% error margin, that's the problem we did before. The 95% error margin is 1.6 hours, and if we take the sample mean 4.55, add this error, we get up point 6.15. So it's going to be this point right here. Okay, so 4.55 is only the sample average. In order to get a range for the population average, what we do is we take the sample average, add the error. The error is 1.6, so you will get this. You get up range for mu 6.15, and you subtract 1.6 from the sample mean, you get 2.95. So what we say is the population mean. So that's the average number of community service hours for all students in the campus is a number between 2.95 and less than 6.15. So it's not going to be bigger than 6.15. It's not going to be smaller. So it's greater than 2.95 and smaller than 6.15. But when you say this, you can only say I'm 95% sure the population mean, the average number of hours of the entire university is between these two numbers. It's within this interval, this range, and you're not 100% sure. But 95% sure is still pretty good. Okay, so this is the formula to find the confidence interval. So you will say maybe you're 95% sure, you're 90% sure, 80% sure, 98% sure, and you can find the population mean. By the way, the homework, one of the questions is 98% confident, and in this case, what you need is 98% the z value, the z score is you're gonna be using is 2.33, and for 95% from that table here, because the table given in the class or in the book, we didn't have 98%. So if you want, you can write it down 98. It's 2.33, and so we have a few minutes left here. We can talk about how to find this value if it's a value not in the table. So what we do is, we know this 99% is sure, 95% is sure, 90% is sure. It's the area under the curve, under the normal standard deviation curve. So it's the it's kind of like we're saying we know the area under this curve is 0.954. How do we find this value here? And that's the last homework question we talked about before. We know the value, the area. We want to find out the z value. So what we do is, like before, we go to use this normal standard deviation table, which is posted under week 7, or you can use the book if you have the book, normal standard deviation. Week number week number 6. Okay, so we look at the table. So we know the area is let's look at again, 0.954. So that is right from here to here. So the total area under the curve is 1. So 1 minus point, we do a calculation here. 1 minus 0.954 equals 0.046. And that is this two white part. So right, little here and a little here. We want actually this little part. So we take, and then we take 0.046 and divide by 2. We got 0.023. So this is the area, this little piece right here. Okay, so left side, and the reason we try to find this area is like the homework, because we know that we cannot, the table we have is for the left side, so this area would be 0.023. So we go back to the table to find the 0.023. 0.023, because this is 0.028, 0.029, 0.029, and so it's kind of between these two, and so the answer is negative 0.023 is this 228, and this, it's between these two values actually, these two values. Okay, so this is 0.0233, and this is 0.0228. So it's sort of between, so I'm gonna just take this value here, and that's negative 1.96, negative 1.99. Well, it should be a value between, but so actually we use the negative, it's negative 1.96, but approximation is negative 1.99, and this is for because it's on the left side, and the z value we usually take the positive one because it's symmetric. So we go back to the presentation. So this value here is negative 1.96, and negative, this is positive 1.96. So this value and this value right here. Okay, so the 98%, how do I know it's 2.33? Because 98% means the area under the curve is 98. If I want to do 98%, I'll do a new page here. Okay, so if I want to do 98%, which is equal to 0.998, so that's the area between those, between these two, the shaded area. So I want to find out these two white areas. So I do 1 minus 0.98, which is equal to 0.02. And then I take 0.02 divided by 2, which is 0.01. So that is the area, this little piece here. Again, this is 0.98. 1 minus that, you get this little piece, and this little piece divided by 2, you get this little piece. And I can use 0.01 to look into the table. Okay, let's see the table here. 0.01. Go down. 0.01. It's right here. The area. Okay, right here. It's between, sort of between these two. 0. Sorry, no. Should be between these two. Okay, so this is 0.01. This is 0.009. So it's between these two values, and it's negative 2.3, between negative 2.22 and negative 2.3. So if I just take this value, negative 2.3 for the z value. So I found out the z value here. Again, this is the area or probability. So the z value is equal to negative negative 2.33, and usually